Okay, one final thing to say about rising air, and that is that there's one specific mechanism that is very important here in the San Francisco Bay Area that greatly influences precipitation patterns, and I think I would not be doing this investigation justice if I didn't mention it. And it's called topographic lifting. So, if you take a look, the San Francisco Bay Area has a lot of mountains surrounding it. Some as high as 3, 4, 5,000 feet, so they're pretty decent sized mountains, not just tiny little hills. There's some pretty decent sized mountains. And that being said, oftentimes these mountains greatly influence air as it moves up and over them. And what will actually happen is if you have wind coming off the ocean and hitting the mountain, this side of the mountain is what's called the windward side, basically the side that's facing the wind. That air is then forced to rise up the mountain. It doesn't matter if the atmosphere is stable or not, it's forced to rise up because it has nowhere else to go. It can only go up. And as it's going up, it expands, cools, and condenses. And that creates a lot of clouds and a lot of rain. However, what happens though is as this rain is falling out, the air is getting drier and drier and drier. Why? Because it's losing water. As rain is falling out, it's losing water. By the time it reaches the top of the mountain, it's very dry. And as it comes down the other side of the mountain, it ends up compressing. It doesn't gain that moisture back. The moisture doesn't magically reappear. Once it's gone, it's gone. That being said, as this air comes down the other side of the mountain, it compresses dry adiabatically. So instead of cooling at that slower rate, instead of warming at that slower rate, the moist elapse rate, it's going to be warming at the dry elapse rate, which is faster. So it quickly becomes hotter, hotter, and hotter by the time it reaches the bottom of the leeward side of the mountain. Now this is the other side, the side that is not facing the wind. Once it reaches the bottom, it's a lot hotter. And a really cool example of this is one that we have right here. Santa Cruz, just over the Santa Cruz Mountains on the other side of Silicon Valley, gets rainfall values of up to 32 inches per year on average. On the other hand, San Jose, on the other side, the leeward side of the mountains in the valley, only receives about 15 inches of rain a year. So this does have major implications on local precipitation patterns.